Hi everyone. Today we're going to take a deep dive into Django models. For our demonstration, we're going to take this simple database design article that I wrote and we're going to codify it using Django models to understand kind of how you create a model, how you associate a many-to-one relationship, as well as how to create a many-to-many relationship with this data. So in this article here, we originally had a table with this set of information here that contained employee record details. And once we took a deeper dive into that, we were able to deconstruct the information into three separate tables. The first table consisted of just the employee information, starting in column A and moving all the way over to column H, and we called this the employee table. We then took the address information for the employee, starting at column I, and including everything up into column M, and created an address table. Now, an employee originally, or in our business constraint, an employee can have one address associated with them. However, an address can also be associated with more than one employee. So in this case, Jane Doe and John Doe both have the same home address. So we have a many-to-one association here where one address can be associated with many employees. Finally, what we did is we took this phone number list where you can have a home phone number, a mobile phone number, and a work phone number associated with an employee, and we broke it down into a table containing just phone numbers, including the type of phone number. Now, our business model states that an employee should have a home phone number, a mobile phone number, and a work phone number, but we also should be able to associate the same phone numbers with more than one employee. So in this case, we will have a many-to-many association between the phone number table and our employee table. So as we can see here for John and Jane Doe, their home phone number is both the same. So we need to be able to go back and forth between those two tables to figure out which phone number belongs to an employee or employees, and which employees' phone numbers or which phone numbers the employee has. So for our demonstration today, I have created a new set of models here that basically take everything that we deconstructed into a database design and created the models necessary for us to interact with a database within Django. Now, the Django models themselves are defined using the models.model base class from the Django DB package. By inheriting that package, we can create a table based on this class and store our records in that table. To create the individual columns within a table, all we need to do is specify a class level attribute for each of the columns that we want to create. So here we can see that we have for the address, we have an address ID, which is our primary key. We have a street number, which is an integer field, and we have our street name, which is a character field, and on and on and on until we get our complete table. Now, if we don't define a primary key within our model here, Django will automatically create the primary key for us. So if I had not have included this address ID with the primary key tag here set to true, then Django would have automatically, under the hood as part of the base model class, would have created the field when we go ahead and create the tables. However, as I like to control the names of these fields, I often override the ID or the primary key field by simply using an auto field, which is basically an integer field with an auto increment setup on it. So if you were to look in the back end of most databases, this just associates a sequence with the table so that every time we create a new record, it automatically increments that value and then takes that value and ties it to that record. Now, the other thing, the next thing that we're going to talk about here is the validators controls. Now, many of these fields have a number of keyword arguments that you can pass to controls constraints on these objects. So, for example, our character field here, we can set the maximum length to equal 100 characters, and when the database gets created or the table gets created, it will set the generally a varchar to be 100 characters in length. However, some of these fields only have certain values. So for example, our integer field here doesn't have a min and max value that we can set. So if we wanted to have a number that started at 1 and could go to infinity, then or until the maximum value of that field length, then we need to use these validators. So essentially, validators are just callable objects. Often they can be either just a function that you define, or they can also be a class. There's a whole entire section within the Django documentation that talks about creating validators and how you can import from a base validator to create your validator. In our case here, we're going to actually just use one of the built-in validators called min value validator, which simply states, I want to make sure that this integer field is always greater than or equal to the value of 1. If I needed to specify a maximum, I could also include this. This accepts a list of validators and runs them in the order that they're received. So if we wanted our values to be from 1 to, say, 255, we could say min value validator of 1 like we have here, and then put a comma and add the other validator called max value validator. Now, most of the validators are included in this in the Django.core.validators package. So you can see here I have included both of those, as you'll see further on down in the model design. Now, down here for the provinces, we want to give the user a list of choices instead of allowing them to put in whatever province name they want. Now, choices allows us to control what the user will input, so we don't run into issues such as inverted characters or misspelled names or any of that kind of stuff. So what we do to set up choices is we simply create this character field, and then we give it a list of a tuple set. So up here we can see here that we have a list of provinces, and we have many different tuples. Now the first value here, this one that's all in uppercase, is what's actually going to be stored within the database. So to keep everything consistent, I have used all uppercase for all the province list. The second value is actually what's going to be displayed to the user. Now this is a little bit further on in the tutorials, but when you start using forms to display this information to users or to ask users for input, you can tie your form class directly to a model class, and when you render the HTML page from Django, the second value is what is actually going to appear on the screen to the user. So to keep things easier to read for the user, we've used the proper casing to spell out the names instead of just using uppercase. So down here we now have set those values, and we've also set the maximum length of this character field to be about 100 characters. So this is still going to be a varchar field of 100 characters, so none of these fields are actually 100 characters in length. So this is just a precautionary future case where maybe there'll be a province with a much longer name. Now, if we try to insert values using this model and we don't provide one of these values, we will get a validation error or a value error exception when we try to save the model. So keep that in mind. It's best to give your users choices whenever possible instead of allowing them to just type in the data if it's already available to them. Now down here we have overridden the save method. So whenever you create a model and you create an instance of it, once you have all the data filled in, you can execute the save function, and that will connect to the database and insert the new record based on the data you've put. Now, normally this will also run through some validation. So for example, if our street name had a value that was larger than 100 characters, when we execute the save method, it's going to raise a validation error. However, one of the things that the model doesn't do is it doesn't actually execute the validators if we're using the model directly to save the data. The reason for this is the the save function in the default class will only call the clean method to ensure that your data meets the minimum validation rules. So what we need to do is to be on the safe side and make sure that everything's validated correctly, including running through our validators, is we need to execute this full clean option. Now there's 3 different clean methods within the model, and calling full clean will actually execute all 3, and if there's any errors in any one of those clean methods, then it will raise a validation error, and it will stop it from being saved to the database until the issue's been corrected. So what we've done here is we've essentially overridden this default save method, and we make sure that the full clean method is called. If that returns everything as being okay, no exceptions are raised, then we'll go ahead and proceed with the standard save method to save it to the database. And in this case, we'll call it from the superclass or the parent class and allow it to save based on the parameters that were originally passed into the function. One thing to keep in mind too with this is if you're using forms, a form model to map the information a user provides back to this model, then this method's not technically required, as the form model itself will actually call the full clean. However, again, this could be a safety net if I'm using a script to insert a bunch of records that may be just an enumeration or a list. For example, if we wanted to create a provinces table and we just wanted to insert a list of provinces, well, then I could go ahead and just create a script that calls this and then just calls the save method, and I don't have to worry about any data being invalid at that particular point. So that's our address table. And if we take a look further down here, we will have our phone number table, which looks very similar to our address table. So we create an ID for our phone number. Once again, this is just an auto field marked as a primary key. And this time we're going to create a big integer field with validators for both min and max. So in this case, we chose the big integer field because the integer field has a limit of 2 billion, and our maximum value is actually 10 billion in this particular case. So in order to have the right model size, we go ahead and we create the bigger integer field so that the data can be stored correctly. And then finally, we create our phone type, which is once again just a list of types of phones that can be associated with a phone number. And we also include the other option in this case, just in case somebody is entering a phone number and it doesn't fit into one of the models that are presented available for them. So we simply set the max length of that again to 10 just to give it some extra space, and then we override the clean or the save method. Now, if we take a look at our employee class, we're going to see a couple of new things in this class. So as I said previously, the address table and the phone number table have a relationship with the employee. So an employee can have one address and an employee can have up to 3 numbers. There's nothing saying that the employee can't have more numbers based on the model that we've created here, but based on our data set, it looks like they will have at most 3 numbers. We also are no longer tied to having to have 3 numbers. Maybe the user only has a mobile number as well as a work phone number and they don't have a home phone number. Then we can utilize this to store 1 or more or none, if we really desire, phone numbers for that employee. So down here, most of the stuff looks very familiar. So we override the ID to make sure it's called employee ID. So we're using an auto field once again. However, if you do want to pick your employee IDs and you're going to always ensure that there is an employee ID that's unique, say they don't start at 1, what we could always do is we could change this to an integer field. So if we take this here, we'll just change this to an integer field. We'll leave it set as primary. And what we'll do is we want to make sure that it's unique. So technically speaking, primary key will make it unique. However, just to be on the safe side, if we want to be overly cautious, we can say unique equals true as well. So now if we use this employee ID field, anytime an entry is created, this employee ID value must be set to a unique value. If it appears anywhere in the employee column when you go to save, this will raise an error. Once again, the primary key already takes care of this uniqueness constraint, but if you're not setting it as the primary key, you can always still use the unique value there instead. However, for our demonstration, we'll just use the auto field ID for our particular example, and we'll see that it just increments just like any other field. So our last name, age, and our first name, you'll notice are very similar, same as our genders, hair color, and eye color and social insurance numbers. So nothing new to cover in this. We're once again using choices. We have a couple of validators on these as well, and some of the standard fields. Now, once we get to the address field, what we want to do is we want to mark the address table as being a foreign key. So we want to basically say in the in the address table, there's a primary key in this case, and we want to associate that primary key directly to this table as a foreign key. So in other words, if we create an employee record and we set the address ID to a value of 1, we then can reference the address table for address ID of 1 to find out what their address is. So essentially that's all this is doing. So the foreign key itself specifies that this is a foreign key in this table. We're going to look at the primary key in the address table because we haven't specified it, and then we're going to also delete ourselves whenever the address field is deleted itself. So what this is saying is if we have an employee and an address in our database and we go in and we delete the address, in this particular case, the cascading method will cause that employee to also be deleted. So caution needs to be taken care here when deleting objects. Generally, you're not going to go in and delete objects anyways, but if you wanted to keep that so that their relationships delete them across all your tables, that's when you would use Cascade. Now, two other options that are available are the null. So if we set it models.null, so what'll happen at that point is in the employee table, whenever the address entry is deleted from the address table, we will have the address ID field set to null in the employees table. If we set it to do nothing, then it'll do exactly that. It will not update the employee table when the address entry gets deleted. At that point, you'll have an employee with an address ID, but when you look up the address ID, you will not find a corresponding record if it got deleted from the address table. So this creates our many-to-one association. You only need to create this in the table that has the foreign key. So in our case, the employee has the address ID field, so we're going to put that there. Okay. Now our next one takes a bit more explaining to understand. So our phone number field, as we mentioned, can have or has a many-to-many association, meaning an employee can have one or more phone numbers, and a phone number can belong to one or more employees. So when we're defining the many-to-many field, the best way to figure out where the many-to-many field needs to go is to ask who has the relationship. So for example, our employee has a phone number. That makes sense. That sounds logical. However, a phone number does not have an employee. So based on those two sentences, we can determine that the many-to-many field needs to be placed in the employee field. Now, this does not need to be defined in both tables, so we do not need to go to the phone number field, the phone number table. So if we head back up here, you'll notice I do not have anything about that many-to-many field. That's fine. We can always find out that information later by looking at the bridging table. So what this many-to-many will actually do is it will go ahead and it'll create the bridging table, so we can always look up a phone number for an employee, or we can always look up a phone number and then find out which employees have that phone number. And that's really all this is doing. So very much like the foreign key, we can specify what table to look at when we're doing lookups for the phone number. Okay. And then, so here we go, we have our override method once again, and that seems pretty straightforward. Once again, we just override it so that we make sure that all validations are checked, and then we save it if everything looks good. Now, to begin, what I'm going to do is I'm going to create the new database, and we'll create the models, and we'll insert some data. So if we open up a terminal here, we can, within the Django project, we have this manage file. So the first thing to do whenever you've either set up a new models or you've made changes to your models is you need to make a migration file. So if we just type in Python against the manage py file, we can then say make migrations. So what this is going to do is it's going to take a look at all the models within your various applications, and it's going to look for changes. So this may be creating new tables if we created new classes. It could be changing to changes to the existing fields, and it could be just even validation changes, which don't necessarily get pushed into the database. Now, if you once you execute this, it will just tell you what it kind of did. So in this case, this is our first migration. So you'll see that we have our initial 001 underscore initial. Every time we make changes, it's going to create this new py file, and this number will increment and it'll have a name beside it. Now these files, when we run the next command, will execute in order. So if we were to make a number of changes and we had, say, 5 or 6 of these files, when we do manage py migrate, it's going to execute 0001 and then 0002 and so forth to apply all those changes. Now, this is only creating tables and altering tables. This is not inserting any new data. So if you have any data within the database, at this point, nothing will have changed and your data will remain in place. And so you can see here that we created 3 new models. If we made some updates, it would indicate that we've modified those tables and it's going to apply those changes. So now you'll notice here that we have this DB SQL file. So if we take a quick peek into that file, so we have our database browser here for SQLite. So we'll go ahead and open the database. What you'll see is there's no tables or anything. At this point, the only thing this table or this file contains is just a placeholder. Nothing has actually been created. And you can see that. We tried to open the file. There's actually nothing inside of it. So to go ahead and set up the table, we can now execute the manage file again. And this time we will run the migrate action. So the migrate, like I said, will execute all those files, and you can see here that is running through a whole bunch of changes. Now, this is the first time we're doing it, so we're going to see a whole bunch of other stuff specifically for our Django session. So this is going to create all of our authorization tables, some of our content and session tables, all that kind of stuff. If we run this again after making changes, we won't see any of that stuff. This stuff always appears on our first initial migrate command. However, up on the top here, we can see that our basic model initialize has been run, and you can see there was no errors. And if we take a look at our tables now, we'll just reopen it, you can see that we have a whole bunch of tables and a number of indexes. So the way that Django works when creating tables is it creates the table called based on the class name and the package it came from. So from here, we can see that our basic modeling folder has an addresses table, same as our employee and our employee phone number. Now this fourth table here, this is our bridging table. This is from our many-to-many association and should only contain our employee ID as well as our phone number. You can ignore the ID in here. This is just to make it unique, and it's just part of what the many-to-many association does. If we take a look at these individual fields, you can see that the individual column names are also named after the attributes that we set within our class. So we have all our different fields in here, and you can also see kind of what they've been made. So like our last name, for example, in our employee is consisting of a varchar of 255 characters, and we do not want it to be null, so it must contain a value. And if we take a look at the data within those fields, you'll notice that in this case, here's our address table, there's no data. So this is what I mentioned, how it doesn't insert any data for us. If we take a look at, say, our employees, same thing, no data is available within there. Okay. So at this point, our table or our databases, our tables and our database is ready. If you're, by default, it will use SQLite. If you've set up your settings file, you can also swap in different types of databases, such as a Postgres database. The information that we're showing here should, for the most part, work within all the different databases, as this is more of an abstraction, and the database engines that are available should take care of the details on how to make that happen within the tables. So now that we have our database tables created, let's go ahead and see how we actually work with those tables. Now, there's a couple of ways we can go about doing this. We can use the manage script to launch a shell. So for example, if I wanted to launch a shell and execute within the IPython interpreter, I can go ahead and type that, and this will set up the Django environment for us. And then, so now we can actually import our models and start working with those models as we need to. However, in this case, I have a script set up that shows us how to do this, which we can also use. So if you want to insert a bunch of data, say you have some data loading to do ahead of time, you can also create scripts to take care of the setup for you. So the first thing that needs to be done if you're going to create a script is you absolutely need to set up the Django framework. So from here, you can see that I imported the Django package, and then I set this Django settings module, which is just going to be a string that contains the path to your settings file. So for example, here our project is called Django Modeling. So when we created our Django our Django project, we called it Django Modeling. And inside here, we have the settings file, settings.py. So in our string here, we call Django model, and then we use the dot, just like we do when we're importing something, and then settings minus the py package extension. And this simply tells Django where to find our settings file. We then call Django setup to set up the environment so that when we start interacting with it, it's ready and prepared to take our requests. Now this works a little bit different than running, say, the run server or executing this as a WSGI application. However, if this is not done and we try to do the next step, which is importing our models, you will actually get an exception because much of the Django framework is designed to have that environment set up ahead of time. So this is just some boilerplate that you can just type into any script that you want to run, and then you can go ahead and execute. Now the rest of this is actually interacting with the database, and what we're going to do is just create a simple employee based on the first record we have in our table. So we can see here we have John Doe. He's a 37-year-old male with brown hair and hazel eyes, and the rest of the information that's stored there. So if we come back to our application, what we'll do is we'll actually go ahead and set a breakpoint on this line here, and I'll walk through the code as it's executing. So to set a breakpoint within VS Code, what you can do is put your cursor where you want the breakpoint to start and simply press the F9 key on your keyboard. What that'll do is it'll put this little dot here, and then when we run the Python interpreter in debug mode from VS Code, it will start this script and then it'll stop at this particular point, allowing us to step through the code one line at a time. So let's go ahead and launch that. So if we come over here to debug and click on start debugging or press F5, it'll then ask us what we want to do. So in this case, we want to execute the Python file that's open. So we're just going to go ahead and click on that. And then momentarily, we will see that our debugger has loaded. So we can see that this line here is highlighted. It's telling us that it's stopped at this line. It hasn't executed it yet. And then we can see any of our variables on the left-hand side here. So as we haven't created any variables yet, there's not much to look at over here. However, on the top here, we can look at the different steps. So for our demonstration, we're just going to step over each of the lines so we don't go into the details or into the class itself. We only want to kind of see how this is working and then look at the database as it's making changes. So in our first step here, we go ahead and we just import the 3 models that we created, giving us access to the tables themselves. So let's go ahead and step over that. Now on our next line here, what we're going to do is we're going to create an instance of an employee without an employee ID. So we cannot specify the employee ID in this particular case because we have an auto field for this employee. So sorry, this is going to create the address for that employee. So we cannot create the address ID. Again, same reason, it's an auto field, but we can specify all the other different parameters based on the model that we created. So you can see that the address class takes a set of keyword arguments, and those keyword arguments are based on the fields that we created in our model. So if we take a look at our model for our address, we have all these fields and we can refer to each one with a key and value pair. So over here we set the street number, then the street name, the city, and so forth. And notice again in our choices, we actually choose the uppercase one, otherwise it will error when we try to save it. So at this point, if we were to inspect this, so let's go ahead and step over it. So on the left-hand side here, we have our address record, and we can see that the address ID field does not exist in here. It's not yet been initialized. Sorry, it does exist. It's set to none. And that's fine because when we execute the save method, that will actually reach out to the database, create the record, and then populate this field. Now, before I click the save method, if we just take a quick peek over at our address table here again and just refresh, there's no field. So if we go ahead and step over it, we can see now that it's on the next line here. And if we refresh our table, the information will be available in our view here. So if we make it a little bit bigger, we can see all the information. Here's our address ID. And if we take a look now at our address ID here, you can see that it's been populated with the value of 1. Now, once you've created the employee information, or sorry, the address information, we could also directly access those individual fields by using the variable name dot the value. So for example, if we wanted to look at the city that's set there, we could do e1 underscore address dot city to get the value that's set, even after we've saved it. So down here on step number 3, same idea. We're going to create a phone number, and we're actually going to create all 3 phone numbers. Now, further down here, we'll explain why we're doing this, but we're going to save these as well to the database before we actually create our employee record. And the order of creation here is important because in order for us to have our references set up correctly for our many-to-one and our many-to-many, the values have to be available in the tables where the primary keys are set. Otherwise, the foreign key that exists in any of the other tables will not be available, and you'll get an error because it can't reference that field. So let's go ahead and step over these values. So once again, we set the phone number for home, for mobile, and for the work phone. And if we collapse the address here, we can see now that we have our home phone number, our mobile phone number, and our work phone number within our variables. So down here on step number 4, we're going to create our employee. Now, with a many-to-many association, the first thing that has to be done, again, is you have to create your employee and then save it before you can assign any of the many-to-many relationships. The many-to-one relationship has to be set up in that employee, though, however, before you save the information. So you can see down here, we're going to create this employee called John Doe, And if we look at the fields, there's going to be two fields absent. So we're not going to specify the address. We could specify it in this case. And then we're not going to specify the phone numbers that we want to associate with this employee. So we create our employee, and then we assign that employee to an address record. So if we take a look at this address again, we're going to actually go ahead and take a look at our address here. We're going to tie it directly to address ID 1. So under the hood, even though we're giving it the whole entire record for that address, the SQL information that's going to get saved to the database is just going to be the address ID of 1. So if we go ahead and we take a look at our employees first off, we'll notice that there's nothing here, but we have this address ID field and we have an employee ID. So this address ID will actually help us search within the address field for this ID here. So this is our primary key, and once again, the employee, this is our foreign key, or the way we use to look up the information in the other table. So let's go ahead and do that. So we'll step over, and so now we have the employee ID, and we have the address. So again, the many-to-one association can be set here, the many-to-many cannot, because the many-to-many will actually create another table. So let's go ahead and save, and then I'll talk more about that in a moment. Okay, so here's our employee record. So you can see now that our employee information has been saved. We now have the address ID of 1, and if we take a look at our address field, that matches up with this guy over here. And so now we can tell where our employee lives. However, if we take a look back at the employee again, what you will notice is the address field, the phone number field, there's nothing in this table that references the phone number. So how does an employee have a phone number if there's nothing in this table to reference that? Let's take a quick peek at the phone numbers here. So once again, there's nothing in here that you can see that matches this phone number table with the employee. What actually happens in a many-to-many relationship, as I discussed in the article, is a third table is created called a bridging table. And that bridging table will have both the employee ID and the phone number ID. And together, these two allow us to find an employee that's associated with this record and the phone number that's associated with this record. So we could say, start with a search for employee number 1, which will give us back John. We can then take a look for our employee phone numbers and say, give me the ID give me the record where the employee ID is equal to 1. And so it'll give us back a set of phone numbers. It could be 1, could be 0, could be many. And then whatever results from are available in here, we can take a look at each of the phone number IDs, which we make it bigger here. It'll give us a list. We can then take that information and match it up with our phone number ID. So if we had our employee who has 3 phone numbers in this case, then we can see that the information gets pulled in from there. And that's really all the many-to-many relationship is doing, is it's creating that bridging table for us. So this is why we need to save, because in order for that bridging table to work, we need both an employee ID, which is not available until we save it, and we need a phone number ID, which is also not available until we save it, because they're auto-incrementing fields. If you had a field where the ID was allowed to be set, you could potentially create it, but I would still recommend that you save the employee record first and then create your bridging table. That way your information is stored correctly when you go to retrieve it. So let's go ahead and see how we actually set up those many-to-manys. Now, here we are going to do is we're going to take employee 1 and we're going to add the home phone number for that employee. So we simply just pass in the employee's home phone number. So in this case, we labeled it employee 1, but it doesn't have to be labeled that way. It's just an instance to our phone number field, as we can see up here, and that will add it to the phone number table. Now, once this executes, this actually will save immediately. So you do not need to call the save method. So before we go ahead and show that, if we take a look at our tables here, we can see there's still no records. But if we step over that method and take a look back at our tables, we can see here now that we have our employee ID 1 and our phone number 1. And that matches up perfectly with our employee ID John, so ID of 1, and our our phone number field of 1. So in this case, we can see that we've now saved that employee's home phone number. Now, this function is not limited to only one phone number at a time. You can pass in a list of phone numbers, or in this case, I'm just passing in a number of different arguments. So I'm going to pass in the phone number and I'm going to pass in the work phone number all in a single call. So if we go ahead and we step over that, we can see now that the script is ended. If we take a look at our phone number field again, we now have 3 records. And in this particular case, we can see that employee 1 in all 3 of these cases has these 3 phone numbers associated with them. And so we can go ahead and execute those queries if we wanted. We can also search for that employee information. So let me demonstrate that here. So let's open up an interpreter once again. So we'll use the manage script to launch a shell. Okay, so once again, this actually sets up our database or our Django framework, so we don't need to execute any of the boilerplate, but we can go ahead and import our modeling. So we'll just import our employee. We don't need to worry about the address and the phone number, even though we'll get all that information back when we query for an employee. So let's say I want to search for John. If I use the employee table, I can use this objects instance to actually make different requests to that employee table. So one of the options is to search for a specific employee based on some criteria. So if I wanted to search for John based on his last name, I could type last name equals, and I'll just type in his last name and go ahead and press enter. Now you can also specify additional criteria in here. So we could say we want to look for a last name of Doe and an age greater than some value, and you could do that. Okay, if we take a look, we'll now have a query set that got returned that contains an employee object. We can see how many employees were found based on that query by typing using the count method, and if we want to access the specific record for that for the employee found, in this case we only have the 1, we can use the list subscript to get access to the specific object, and then simply use the field attributes to get the information. So if I take a look at last name, in this case it's Joe or Doe. If I take a look at the first name, we can see it's John, and so forth. So we can take a look at all the different properties, but what we can also do is we can take a look at the address information and the phone number information. So if we pull out the John record and we ask for the address field, okay, at this point what's actually happened is it's reached out to the database and it's asked specifically for that address for that user, for that employee rather. So if we take a look at their street name, we can see that their street name has come back with Burnell Street, just like we had set. Now, to get the individual phone numbers, what we'll need to do is return the query set and extract the individual phone numbers. So to get the query set, we can simply just reassign phone numbers equal to the query set itself. Okay, and so now if we take a look at this here, we can see that we have our query sets and we have our individual phone numbers. So we know for sure this employee has 3 phone numbers. So if we take a look at the individual phone numbers, once again by looking at the subsets there, or subscripts, we can take a look at the phone number for that employee as well as the type. So we can see this is the home phone number in this particular case. So that basically covers most of the information that you need to work with Django models. In our next video, we'll talk about how to take this model and integrate it into the forms model to create HTML forms for the users to either input information or to utilize that information, that form, to display information to a users. Thanks for joining.